using qualitative analysis based on physical property and classification tests, we are going to practice with hydrocarbons and alcohols for the first part 1 and part 2 of the experiment 19. Basically, it's not just the solubility. Experiment 18 explained about solubility, how to find out if based on solubility to determine the functional group. But let's say if you do solubility test and you find out your compound is alcohol, now what you need to do. Because if it's alcohol, then you want to know if the alcohol is a primary alcohol, secondary alcohol, or tertiary alcohol. And then you want to know what is the molar mass for the alcohol. And based on the tables that is provided to you or will be provided to you in order to find the derivatives for the alcohol, then you can find the melting point for the derivatives. And just like following the experiment for experiment 12, then you can determine the name for the compound. So basically, you're practicing. You have 3 days to practice with the known samples. So whatever experiment we are doing today, we already expect the result. We already know what the result is. But that is not the point. The point is to have practice, to train your eyes, to train your mind and your hand in order to record proper data and evidences for the reaction. So based on the evidence for the reaction, then you can look for the unknown and find out your unknown is going to be, what would be your unknown. So when I'm going to perform the experiment for you for the unknown, just a warning that when I'm performing the experiment for the unknown, I'm not going to identify the unknown for you. You are going to look for the evidences from the first part of the experiment 19 for alcohols, for hydrocarbons, are basically alkane and alkene, and then for aldehyde ketones and carboxylic acid, in order to find out what your unknown is. I will do the legwork and say I will do the actual experiment for you. I will show you the evidence. You record your evidences, and then you compare to your lab notebook to see, well, if it was primary alcohol, how would it react with Lucas reagent, or secondary alcohol, how would it react with the Lucas reagent and other reagents that you have. So basically, is a practice. For the procedure for experiment part 1, we are going to find the solubility. That's the first part of the experiment. And then the second part of the experiment, we are going to do classification. Based on the solubility, we are performing the experiment as the procedure indicates. For test tubes, like we have 3 test tubes, we are going to take the naphthalene, toluene, and hexane. I think I'm going to just limit to 1 alkane, 1 alkene, and 1 aromatic compound. So we don't have to do all different tests for all 5 or 6 compounds. Those are the options, which compounds we can use. I'm going to see what is available in the fume hood, and we are going to use those chemicals. So at this point, the experiments that we are going to do is going to be on page 195 hard copy, probably ebook would be 193, and I'm doing the experimental procedure for the solubility, okay? For the experimental procedure for solubility, and we are going to record the observation. Solubility in sulfuric acid. So we are going to determine the solubility in sulfuric acid. Since we already know it's hydrocarbon, do you think hydrocarbon is going to dissolve in water? If it's a hydrocarbon, would it dissolve in water? No. So do we have to even test it since we know already it's hydrocarbon? So that's why the first reaction is looking for the solubility in concentrated sulfuric acid, because water is not a question. We already know that we are dealing with the known sample. It's hydrocarbon. So for hydrocarbon, there is no reason, no need for us to do solubility in water, solubility in sodium hydroxide or HCl. But some hydrocarbons, they dissolve in hydrochloric acid. And if you look at the solubility chart that you had for ebook 180, page 181, and for hard copy is page 183, if you look at the hydrocarbon or solubility in the sulfuric acid, if the compound is soluble in sulfuric acid, is going to be a polar compound. It could be unsaturated, since we're dealing with hydrocarbons at this point. Is going to be unsaturated hydrocarbon. So it could be alkene or alkyne. If your compound does not dissolve, if it's insoluble, it could be aliphatic hydrocarbon or it could be aromatic. So if it's aromatic hydrocarbon, that means it has only carbon and hydrogen and is aromatic, or is aliphatic and it's saturated aliphatic hydrocarbon, is not going to dissolve in concentrated H2SO4. So since you asked me what part of the experiment, one more time, page 195, or solubility in concentrated sulfuric acid. Make a table in your lab notebook and then add the chemicals that we are testing, like that we have available in the fume hood right now. Is not going to be all of them. So your table, it may not have naphthalene, because I don't see the naphthalene there. So just the ones that we have, we are performing the experiment. Your table should be based on the experiments that we are doing in the lab. I'm going to get my gloves because we are working with the sulfuric acid and the test tubes. I'll be right back. Okay. Since we are working with sulfuric acid, I prefer to do this experiment following the safety precautions. I have to do this experiment inside the fume hood. It's not even a choice. So, can you tell me how much I should add? What should I do? What should I do? What's the first step? I know the steps, but I want to make sure I get the answer from you, so it counts for your participation. And you also know which page you should look for the procedure. Okay, what should I do? I'm trying to do the solubility in sulfuric acid. What is the procedure? What should I do? 1 milliliter of sulfuric acid, 5 drops of hydrocarbon. The first hydrocarbon that I chose is hexane. So you can record in your lab notebook. We are testing now for hexane. That's the first hydrocarbon, hexane plus sulfuric acid, and I show you the result. So I'm taking 5 drops of hexane. That didn't go very well, but 5 drops of hexane and 1 milliliter of sulfuric acid. Okay, I have 5 drops of hexane and 1 milliliter of sulfuric acid. Record your observation. What's your observation? It's clear. 2 layers clear. So is it soluble or not soluble? Not soluble. Okay? Not soluble. Next compound that I'm going to test with is 1-pentene, which is the unsaturated hydrocarbon. Again, 5 drops of the hydrocarbon, 1 milliliter of sulfuric acid. Okay. You can take a screenshot of this one because what we have here, that's the 1-pentene, okay? And the clear one is hexane. So you could see also the difference if you have unsaturated or saturated hydrocarbon, how it's going to be, how it's going to react differently. The lab manual, it says 2-pentene, but what we have in the fume hood now is 1-pentene. The idea is not which pentene, the idea is to have a unsaturated, okay, unsaturated hydrocarbon. Any unsaturated hydrocarbon, even the 2-pentene is going to give you same evidence. So if you take the screenshot of this, it's going to help you when you are identifying your unknown, how it's going to look like. That's by comparison. So you could see the difference for unsaturated and for saturated hydrocarbon. The next compound that I'm going to test is toluene. And for toluene is aromatic. And I want to see how aromatic reacts with the sulfuric acid. Okay, that's aromatic hydrocarbon. Record your observation. 2 layers insoluble, clear, no color change. Okay. Okay. So we are done with part A of the experiment. Moving to part B of the experiment, we want to test the hydrocarbons with bromine solution. Bromine solution. Bromine, the reaction of bromine with hydrocarbons, it's very fast and often is used for test for unsaturation. What it means, like it gives you fast and right away results if your compound is, if your hydrocarbon is unsaturated, it's going to react with bromine, and the bromine is going to get change, lose color, or the color of the bromine is going to disappear. So basically the light brown color or brown color of bromine is going to disappear. Now, if your compound is not unsaturated, if it's alkane or saturated hydrocarbon, the reaction with the bromine, it could take place because you learned that in Organic 1, Chapter 4, that you do have free radical chain reaction between halogens and alkane, but that requires heat. So at room temperature is not going to happen. So the positive test with the reaction of bromine solution with the hydrocarbon, it means that your compound is unsaturated. So you can use that for also for the unknown solutions. So we are going to test each of the hydrocarbons that we have again with this time with the bromine solution. Okay. The 5% bromine in methylene chloride, because bromine is not concentrated or is not pure bromine, is a solution of the bromine in methylene chloride. Color of the bromine is like dark red or brown color. And when we add to, I'm going to test with the 1-pentene first. Okay, this is the 1-pentene. Yes, it's part B. It's a 1-pentene. And I'm going to add drops of bromine. Going to bring you closer so I don't leave the fume hood. So inside the fume hood, I'm adding drops of bromine. So after adding bromine to 1-pentene. Okay. What's the evidence? This is the bromine color disappeared. This was the color of the bromine. It disappeared, and it means your compound is unsaturated. Going to test hexane now. With bromine. So reaction of hexane plus bromine. Hexane plus bromine. Record your observation. Okay, bromine, it doesn't dissolve in the hydrocarbon. It reacts with hydrocarbon. just the proper term for it. Bromine is a reaction with the hydrocarbon, not a solubility. Okay, that's for part B, and we have to do one more experiment here. That's toluene. Reaction of toluene with, what do you think of toluene? Do you think toluene would react with bromine or no reaction with bromine? No reaction. Aromatic compounds, even though that's toluene plus bromine. Aromatic compounds, even though they have pi bonds, but their pi system is the identity for aromatic compound. Aromatic compounds do not want to lose stability, and they don't want to lose that pi bond. So there is no addition reaction between aromatic ring and bromine reagent or bromine solution. So same three chemicals with the with bromine. There is a typo here, needs to be fixed. Let me get. Okay, next one. Potassium permanganate solution with the hydrocarbon. What do you expect? What is going to happen if you add potassium permanganate? Dominic, this is toluene and bromine. What's next reaction? Permanganate, potassium permanganate with hydrocarbon. What do you expect? What are you looking for the next reaction? It's the Bayer's test, yes. But with the Bayer's test, what do you expect? What's going to happen? What type of evidence you are looking for? Purple color to disappear. It is a oxidation reduction reaction. So permanganate is purple color. If the reaction takes place, the color of the permanganate is going to change from purple color to brown color because permanganate is going to be reduced. Permanganate is oxidizing agent. The oxidizing agent of permanganate is going to be reduced itself. So permanganate would change to manganese dioxide, MnO2, same product you had for experiment 12, the brown color that you got precipitate. But if there is no reaction, the purple color would stay. So this is the first reaction, and that is the reaction of hexane with permanganate. Okay, hexane with permanganate. Now I'm going to move with pentene. The 1-pentene with permanganate. Okay. Do you see the color change? What does it mean I'm glitchy? Is maybe is it my voice that is not good with the when I'm standing next to fume hood? So should I move outside of the fume hood, or the internet is not good? Oh, the video. Okay. So okay. Evidence for the reaction for permanganate. Evidence for the reaction for permanganate. Permanganate with pentene, which is the alkene, permanganate with alkane or hexane. Okay? Record your observation for the permanganate. This is for pentene. And that's another reaction. The other compound was toluene, so we're going to test the permanganate with toluene. Permanganate with toluene also has no reaction. Okay, so you can take a screenshot of this. But you need to label it later for your report or for your evidences. The one in the middle, this one is pentene, aromatic and saturated. Okay, next we are going to work with the second class of the compounds, and that is alcohols. I'm moving to the next fume hood. We just make sure we get another test tube back. Okay. So tell me what I need to do for alcohols. What are the different type of reactions that you would expect from alcohols? Since that was chapter 1 in your Grignard, so we're not doing Grignard reaction now as the qualitative analysis, but you can prepare alcohols using Grignard reagents, right? Based on the lab manual, which reactions are we going to perform for alcohols to classify as a classification test for alcohols? So Grignard reaction is to prepare alcohol. Hydration of alkene is to prepare. Substitution reaction with SN1 or SN2, that's to prepare alcohols. But we are looking for reactions of the alcohol. the first reaction, first we want to know we have alcohol or not. What is the classification? Steric nitrate test. Okay, good, very good. Sorry, I didn't see that part. So we do the steric nitrate test. If it's positive, what does it mean? If steric nitrate is positive, what does it mean? That's what we are trying to kind of here. As a result, I want to make sure everyone understands what does it mean if you have steric nitrate test positive. I'm just pouring some alcohol into beaker. I'm not doing experiment. When I do experiment, I show you. So I'm just pouring some alcohol into the beakers. And I'm waiting also for your answer. What happens if you have a positive test for steric nitrate? What does it mean? What does it actually mean? Okay, we are looking for two things. One, what is the evidence for the reaction? Like if you add steric nitrate reagent to alcohol, what would be the evidence that you could say, yes, chemical reaction took place, or the test was positive? So you need to know what the evidence is before, so you get like a red, okay, red color, that is the evidence for reaction, a red complex. That's evidence for reaction. Now, if you get red color with steric nitrate, what does it mean? That means your compound is alcohol, right? It's either primary, secondary, or tertiary alcohol. So we are going to get the quantity, how much we're adding. 5 drops of the sample and 1 milliliter. Okay. Okay, I have the 3 alcohols from right to left. I'm actually going to do differently. I'm going to actually label this so you could see it. Okay, and I'm going to read it to you so you know what they are. I have a primary, secondary, and tertiary alcohol. I'm going to add the steric nitrate reagent to each one. 20 drops is 1 milliliter. So I'm basically counting the drops. I'm adding 20 drops to each. Okay. Right now, the evidence for the reaction is the dark red color or the red complex. Is not very exciting because you already knew this is alcohol. But if your unknown, it gives this color, then you confirm your unknown is alcohol, then it's good, then it's exciting. But unless you know these, you won't be able to recognize your unknown if it gives you this color. So you need to practice with the known sample. If it's alcohol, it's going to give you red color with steric nitrate. If it can give you red color, that means it's not alcohol. Okay. Any questions? You see it? What is the next test for alcohols? Until you give me the reagents, what I need to do, I'm going to use the time and label my test tubes with primary, secondary, and tertiary. I didn't say to screenshot, but if you did it, it's fine. That's good. You should record the evidence at least. What is the evidence? Okay, I'm waiting for you to tell me what to do. I only labeled my test tubes as primary, secondary, and tertiary. What should I do next? Add 5 drops of each alcohol to the test tube. Okay. I'm adding. And next, add the 1 milliliter of the Lucas reagent. Okay. Okay. 1 milliliter of Lucas reagent. What do you see? Do you see the labels? Is the labels clear? Are the labels clear? Yes, okay. For tertiary, it turned cloudy right away. So if you test with ferric nitrate and you know you have alcohol, then you test with Lucas reagent, and if it turns cloudy right away, that means your alcohol is tertiary. So tertiary alcohol turns cloudy right away. It's a fast reaction because this reaction has carbocation intermediate, and with the carbocation intermediate, tertiary is going to go faster than secondary than primary. For secondary, okay, for secondary, and primary, there is no precipitate yet, but secondary is kind of getting cloudy. I don't know how to show you, so you could see that there are some particles. Maybe black background can help you to see it. Do you see the particles? The color has changed and there's like particles floating. Okay, perfect. So there are some particles floating. This is a secondary, but it's not as fast as the tertiary. For primary, nothing happened. So for primary, it's all clear, no reaction. It takes very long time, and the long time, it could be like 1 hour. So we're not going to wait for that. We just say no reaction, some reaction with secondary, and immediate and fast reaction with tertiary. So you can, if you want to take a screenshot. So when you take a screenshot, you could see that this one, it's different from the primary. It's more cloudy than the primary. Your primary is your blank, tertiary fast, secondary is slow. And no reaction with the primary. That milky white, it means that a precipitate has formed. Okay, what's your next experiment? Which part of the experiment you want me to do? No, particles are white. White precipitate is zinc chloride. Yes. Particles are the next, Jones oxidation. With the Jones oxidation, your reagent is basically chromic acid, and chromic acid is oxidizing agent. What do you expect? Can you tell me what you expect from this reaction? I want to know, you already have read the experiment, or hopefully this was covered in your lecture already, and you remember it. I'm sure it was covered, but you remember. I'm going to label while you're writing your responses. I go back, and please give me evidence and tell me what does it mean. Because if you just give me evidence, I don't have kindergarten anymore, but I used to, when I was teaching, while my children, they were like kindergarten, I say, well, my daughter at age 4 can tell me what color change. I can't use that as her as example anymore, but what I want is what the indication. Evidence is one thing which is very important. We need to have evidence for the reaction, but from the evidence, we have to have a conclusion. And what is our conclusion? What is the evidence first? Second, what is the conclusion? Which that's what you are replying, and I really appreciate for everyone who is participating, actually answering questions, reading the procedure before logging in or joining the meeting, because that is the ideal situation. Okay, so I labeled the primary, secondary, tertiary. What is the procedure now? I need the drop of chromium trioxide reagent, drop of alcohol, and the acetone. Okay. I'm going to add the chemicals and show it to you, and bring it to for the last step. Okay, I added the alcohols already. 1, 2, 3. I'm adding the acetone. And next, I need to add the chromium trioxide reagent. This is the color for chromium trioxide. That's the color of the chromium trioxide. Is an oxidizing agent. And I'm going to add to primary alcohol and see how it's going to be affected. If the color is going to change or not. What do you see here? A green color, what does it mean? What does green color mean? Why primary or secondary? Why is primary or secondary? No, it's alcohol. We found that earlier. Alcohol means that is the ferric nitrate. With this, we can find out if it's primary or secondary. Okay, this is the secondary. And if I add to tertiary, means that primary and secondary are being oxidized, but tertiary is not oxidized. So you could see the colors now. And you could have the result of this experiment as well. Can you see the label and the color? Both? You can take a screenshot. Let me stay back so you could take a screenshot of the tubes. Got it? Okay. It's funny that it's the probably first time I see the exact color that I expect. I do the experiment. Okay, next. Iodoform test. Which alcohol should I be worried about for iodoform test? Do I have to do iodoform test for all 3 alcohols, or which one you think is going to give positive? For the known samples, if it was unknown, I would do it, of course, for the unknown. But for known sample, only OH group, when the OH group is on the second carbon. Okay, so it has to be the OH group on the second carbon, not secondary. Okay, not a secondary. Secondary is not enough information. When you say secondary, secondary could be on the third carbon, secondary could be on the carbon 4 or 5. When the OH is on the second carbon, that means you have CH3, and your CH3 attached to the carbon that carries the OH. Now, iodine, it's an oxidizing agent. So a secondary carbon or secondary alcohol can change to, it can be oxidized to methyl ketone. When it is oxidized to methyl ketone, then with the iodine is going to form, is the iodoform test is going to give you yellow precipitate. So why do we have to do this test now? In part 3 of the experiment, when you are dealing with the aldehydes and ketones, you will see that one way to determine if your unknown is a methyl ketone or not is to test for with the iodoform reagent, or perform the iodoform test. The iodoform test for methyl ketone is going to be positive, for other ketones is not positive. Then, if your unknown was actually a secondary alcohol and you did the iodoform test before performing experiments for the ferric nitrate and all, then you're going to record false positive result, even though it was secondary alcohol, but you recorded as a methyl ketone. So methyl ketone, just like methyl alcohols, just like methyl ketones, can give you positive tests. So we are going to test the secondary alcohol that we have here, but the condition is not just being secondary alcohol. It has to be secondary alcohol, where OH is on the second carbon. So basically, if you oxidize it, it would change to a methyl ketone. I need to get a pair of gloves, and I'll be right back. And we get that experiment. I might do experiment with the primary also, just to see the difference, so you could compare. If it's not a methyl alcohol, how is going to be different. Let me get a glove. Okay, I forgot to ask you to write down the procedure for me while I'm making you wait. So you could write the procedure for me. What do I need to do? What is the quantity? And what are the reagents that I'm adding? Basically, the procedure. So we want to start with the alcohol, right? What's the procedure for Iodifer test? Tell me what to do, please. Water, 2 milliliters of water. Okay. Add a small amount of alcohol, 2 milliliters of water to make sure it dissolves. Okay. It did dissolve. And next, because it dissolved, I don't have to add the lime. So sodium hydroxide, add 1 milliliter of sodium hydroxide, the 10% sodium hydroxide, and I hope it's here. Let's see. We're going to add the 10% of sodium hydroxide. Again, I'm counting the drops, 20 drops of sodium hydroxide. And next, iodine reagent. Going to add 10 drops of the iodine reagent. The color disappeared. Basically, it's going through oxidation reduction reaction. I have to add, how much of iodine solution should I add? There are two conditions that I stop adding iodine solution. I hope that part is clear in the procedure. One condition is I see a yellow precipitate, then I stop. If I see yellow precipitate, I stop. That's one condition. Very good. A second condition is that I see this like orange red color stays here, but no precipitate. It's clear. That means I have added enough iodine. If it would have been positive, it would show positive test. But the red color that stays, or the orange color from iodine that stays, that's not positive test. The positive test is this yellow precipitate that is forming. So if the OH is on carbon 2, just like 2-butanol, you will get positive test with iodine. Now, I'm going to repeat this test. I'm going to repeat it with the primary alcohol, and I want to see what would be the result with the primary alcohol. We usually don't do that part of the experiment, but I want to at least for you to see the difference. Following the same procedure, exactly what you told me for secondary alcohol. Now with the primary alcohol, I'm trying to add the iodine solution. Okay. The yellow color appears, it stays, but no precipitate. You see the white cloud that you have here for secondary alcohol with the methyl alcohol, but this one, no. And it forms like two layers. The key is that there is no white yellow color precipitate like this one. Okay. Now this was that is the, do you see the difference? This one is a 2 butanol, 1 butanol. 2 butanol, it gives positive, but 1 butanol, it gives negative test. Okay. There is no phenol out. Probably I didn't ask for phenol. Let me see what experiments we have for phenol. Hmm. Okay, let me go ask for phenol, and then we can do some of these experiments with the phenol. What time do we have? 1:38. Okay. Don't know. Let me if they need phenol. I said no. We do only hydrocarbon and alcohols. No, I didn't test for the tertiary. I was only we were only supposed to do with the secondary alcohol, but I added the primary for comparison to see the difference. Okay? If to see the compare it as a point of reference. How would it look like if there is no reaction? How would it look like if you have a reaction, if there is a reaction? Okay, be right back with some phenol. You don't have a liquid phenol, right? Is this solid? Okay, while you're waiting for the phenol, I want you to need one spatula and a test tube practice. Is phenol soluble in water? Because the first test for phenol is solubility. Would it dissolve in water? Yes or no? Does phenol dissolve in water? I don't see any response. Can you hear me? Would phenol dissolve in water? Thank you. It's not supposed to, right? It's aromatic compound. So the first solubility is phenol in water. It stays insoluble or partial, slightly soluble because it didn't dissolve. Second is solubility. So that was the first test result. So for those of you with idle, come back, record your data, please. Second one is after testing with water, what's the next solvent that I should test with? Solubility chart or the procedure? Use one of them and tell me. Solubility. We're testing with the solubility. ECl3, that would be ferric chloride. That's for classification tests. Solubility, you have, if you look at the chart, page 181 or 183 for ebook versus hard copy. Then we are going to test with sodium hydroxide. Okay. Is it expected to dissolve in sodium hydroxide? Does it dissolve in sodium hydroxide? Would it dissolve in sodium hydroxide? Is expected, right? And it gives you clear solution. So it's soluble in sodium hydroxide. It wasn't soluble in water, it was soluble in sodium hydroxide. Next, the test, since you have the answer already, sodium bicarbonate. So I take some phenol, small amount of the phenol because I don't want to saturate. I want to see, make sure that if it's soluble, I would see it's soluble. Add sodium bicarbonate. I'm sorry, I used it did dissolve, but I used the wrong solution. It dissolved, but I used the wrong solution. It's a sodium hydroxide. I have to make a new sample now. The sodium bicarbonate. You see the particles? The particles stay there, so it's not soluble in sodium bicarbonate. Soluble in sodium hydroxide, but not soluble in sodium bicarbonate. Next, what's the next reaction or test? Ferric chloride. Okay, we're going to do ferric chloride first, and then ferric chloride first, and then it would be ferric chloride, the phenol, and we want to add the ferric chloride. What do you expect? Formation of a strong color. That means you have phenol, okay, with the ferric chloride. Next one. Ferric nitrate. What do you expect for ferric nitrate? What do you expect to test of phenol with ferric nitrate? Do you remember the color of alcohol with ferric nitrate? It was deep red color, right? But for the ferric nitrate, you get like a brown green color. That means it's not alcohol, it's phenol. Slightly different color. So you get this color for ferric nitrate. For phenol compared to? Oh, ferric nitrate test was before the ferric chloride. My bad. At least we did both of them. Next experiment. Next experiment would be, or the last experiment would be, I just did the ferric nitrate. This was the ferric nitrate. This is the ferric nitrate for phenol. Because ferric nitrate with alcohol was red color. Bromination is next. So bromination of phenol, what do you expect? Decolorization? Okay, let's see. So we are going to take 0.1 gram, about 0.1 gram of the phenol, add water, and next would be add 3 to 4 drops of bromine water. We are looking for the yellow precipitate. So you add the bromine water, have bromine. Okay. The color of the bromine water disappeared. So we add or based on the procedure. See, when I'm adding the bromine water right away, it's still on top of the solution, that white precipitate that is forming. See that? Or the precipitate that is forming, that is the indication of presence of phenol. Okay. That was the last experiment. And I'm going to stop the recording soon. Do you have any questions about this experiment? Questions? I think that would be the solution. To watch the video, hopefully the video was recorded clearly, which I think that should be the case, right? Because my internet, it was just went down once and it came back. Yes, I am. Yes, looks if there is any question about this part of the experiment, like part 1 and 2, I want to be included in the recording, but when we are done with questions with part 1 and 2 of experiment 19, I stop the recording, and then I do again check for attendance, and I will also answer other questions that you might have. No questions? Okay.